This is to connect the dots with what we've been talking about, especially with what we learned yesterday. The questions I was asking yesterday were very repetitive. I was expecting repetitive answers, but honestly, it felt like people were just guessing. Like when I ask you, do we prefer the mean or median as a measure of center? You shouldn't have to guess. Like you should know because it's really easy to look at it with some things. And then if it is, then you prefer the mean. If it's not, then you prefer the mean. So like this is to help practice that. This unit doesn't have you doing a whole lot of solving. That's the next unit. So this unit should be pretty easy in that sense because a lot of the things that we do can be done in the calculator and you just have to know your vocabulary. So this includes a lot of vocabulary. Take the first 5 minutes and do the matches for the first 5, or not 5 rows, 3 rows. These are your options. So I would just put the letter. I wouldn't try copying it until I had time. So just put the letter that goes with the ones for your options for the first 3 rows, and then go back and answer these. Like, is the mean or median preferred? Is a standard deviation, MAD, or IQR preferred? Is it symmetric? So the first 3 rows, you should be picking from these options. That's why I didn't make it double-sided because I wanted you to see all your options. And then you should be able to answer these based off what we did yesterday. Sure. Questions? Okay, so I'm going to start my timer for 5 minutes. You yourself make the most matches that you can and answer the most that you can. 3, tell me one match that you were able to make. A bell-shaped dot plot. Let's take a look. So class, is F a dot plot? Yes. Is it bell-shaped? Yes. Okay, good job. Table 4, tell me another match that you were able to make. For which one? Okay, so let's take a look at G. Class, is that a dot plot? Yes. Is it uniform? Yes. Could it look another way and still be uniform? Yeah. Yes, and you'll see it later, maybe in the next note sheet that we do. But this, where they're all the same height, can also be uniform. Table 6. Tell me another match that you were able to make. On which one? Right? Dot plot histogram. Dot plot. Okay. So 8, let's take a look at it. Do you guys agree that this is skewed right? Yes. Yes. I think it's easiest to look for the void. Like, don't look for where all the data is clustered, because then you'll always get it wrong. But now that you've done the lesson 10-14, you should also kind of connect this too, to help you figure out what way it is skewed. So you guys did lesson 10 and 14 on your own. That was the one you were supposed to watch the video. What else is to the right on this histogram? Or not histogram, dot plot? A potential outlier. I say potential because you have to actually do some calculations to confirm it as an outlier. So anything that's 1.5 times the IQR, above or behind the data will be an outlier. But usually you can assume, and usually you're right, if it's an outlier, it should be away from the data. That outlier is toward the right. So that's why we say it's skewing it right. That pulls the mean in that direction. And when we go to the right on a number line, do the numbers get bigger or smaller? Bigger. So for things like H, we would expect the mean to be higher than the median. Okay, because it's being pulled to the right. So that's why it's skewed right. Questions on that? Okay, we'll be paying attention. So that's a super important concept. Table 1, tell me another match that we were able to make. I is a skewed left dot plot. Let's see. All right, it is a dot plot. It is having a void or potential outlier to the left, so I agree with that. Table 2, tell me another match that we were able to make.
Oh, it's what box.
Okay, so first box plot, let's take a look. So this one is a little less easy to find a void, like the histograms and the dot plots are easier to find a void. So you have to remember that for box plots, what's good about them is you can see how spread out the data is by looking at the quartiles. So the quartiles would be all the vertical lines on the box. So you can see this first 25% of data is more spread out than the other 25%. Like I can barely even fit my pen to write 25% in these other sections. This one is more spread out. So compare it to, you guys said this one was also skewed left. Would you guys say that it's more spread out to the left? So this one is our skewed left box plot. When it's more spread out to the left, that will be our skewed left box plot. All right, now whoever spoke for your group, rotate one to the left. So table 3, tell me a match that you were able to make. You guys have your lefts and rights mixed up.
Is that supposed to be?
And you said E and then elephant? Okay, so let's look at our first histogram of the day. Do you guys agree that that's bimodal?
Yes.
Okay. If you forget what bimodal looks like, just break down the word. What does the prefix bi mean? Two. And then modal sounds like what measure that we talked about? Modes. Good. Now, sometimes they're not perfectly even, like maybe one of these might be a little taller, but we'd still call it bimodal, but that should help you kind of remember, like 2 modes, 2 peaks, like that's what I should be looking for on my data for bimodal. All right, now table 4, tell me another match we were able to make. J is the bimodal dot plot. It's the only dot plot that's left too. So process of elimination, if you were struggling, connect all the ones that you're able to connect, save the harder one for last. But yeah, this one's a good example too, because like this one has the peaks on the very end. They don't have to be on the very end. They just have to be 2 separate, distinct peaks away from the middle to be bimodal. So yes, J is bimodal. Table 6. Tell me another match we were able to make. A is a uniform histogram. Let's take a look. Class, we agree. Uniforms. Is it a histogram? Yes. Okay, great. Table 1. Tell me another match we were able to make. All right. Did you say N or M? Okay, so let's take a look. N is definitely a box plot. Is it out of the ones we've not identified yet? Is it the one that could best be uniform?
Yeah.
There's not one that's better. So box plot. So we're looking at N, we're seeing is N the uniform one.
Oh.
Could it be the uniform one? Potentially. So like if I plot this data into Desmos, it might give me something that looks like that is very symmetric. But N will not be that one. N is better for some other shape on our list. Can we figure out what other shape it's best for? No, N is best for which other shape?
This all have was.
Bell shape is what I was looking for. When I asked for the shape, I was looking for like either bell shape, cube, uniform. That's what I meant. Okay, so the reason why this one is best for bell shapes is because bell shapes is also symmetric and it's like evenly distributed as well, with more of the data being toward the middle and then like tapering off to the ends. So that one is tricky because you can have some uniform distributions that look similar to that. But N actually is the best one for bell shape. And then the others is bell shape. So N has to be the bell. All right, table 2, give me a match that you were able to make.
Speak the distributed.
All right. Class, do you agree that is a cell-shaped histogram? Okay, great. Now rotate again to the left. Whoever spoke first or last, so what to the left. Table 3, tell me another match we were able to make.
Is A for block.
Okay, let's check that out. Box plots. All right. So the ones that are left for box plots are K, M, and O. Do you guys agree that K must be the bimodal one?
Yes.
So bimodal data has 2 peaks, right? What is, I mean, you can't see much of this. What is this on? Like what value? Well, value. It's all on a 5. That means my minimum, maximum, my cube 1, my median, my cube 3 are all 5 if my box plot looks like that. So do we think that that's 2 modes?
No.
So that one shouldn't be my bimodal one. Table 3, do you want to try again?
It's the uniform.
It's the uniform ones. Because that was the other type of uniform you can have where it's all on the same number. So this K is our uniform box plot. And what, because I made this for the district, by the way, I made this whole little activity. When I was making ones for box plots, I literally went into Desmos, I put my data set as all 5s, and then I had it make one and I just took a little screenshot. So that is a good form. You could play around with Desmos too if you were wanting to like make a better match. So that's something you could do. Table 4, tell me another match that we were able to make.
And
The bimodal box plot. And of the 2 box plots that are left, M is the better one because O is obviously what? Good. It's obviously skewed and it's definitely skewed right. If we're being more technical about it. Skewed means not symmetric. Bimodals are typically symmetric. So like between these 2, M is the bimodal one. Now for that one, when I was making it, I went into Desmos because we know we can use Desmos to make some visualizations. Because the bimodal could look a little bit different, like it could have whiskers potentially. But when I entered it, I made sure that I put a lot of the same number toward the ends of the data. I made sure to repeat numbers a little less towards the middle. And then I made sure again, like on each end, that I was getting like the 2 modes. And then in a different cell, I was clicking the functions clicking the box plot because that's what I was trying to make an example of. And you can see you don't see the whiskers because the Q1 and the minimum are the same. The maximum and the Q3 are the same, and you can see what each value is with that stats function we talked about. So that's why you don't see the whiskers. Questions? Okay. So there's that. And let's see, we're on table 6. Tell me another match that we were able to make. Skewed right, B as in boy. All right. Class, do we agree is the void on the right? Okay, good. Also, we identified O, so let's go ahead and put that on ours if we haven't already. O is our skewed right box plot. And then there's only one left. What letter goes here? D as in dog. So that would be our skewed left histogram. And yes, the void is on the left, so that makes sense. So we made all our matches. Questions on making the matches? Any disagreements still? Confusion? Okay. So now we're going to answer these questions about each shape. Because this is what we covered yesterday, and I'm going to tell you, like, I felt like people were just guessing when I was asking, do we prefer the mean or the median? You don't have to guess. No one has to tell you the answer either, because you, if you're paying attention, should just be able to look at it and say, oh yeah, it's this, so we prefer the mean, and so forth. All right. So table 1, whoever my reporter is, if it's bell-shaped, would we prefer the mean or the median? See, I feel like we're not paying attention. Table 1. If it's bell-shaped, do we prefer the mean or the median? The mean. Do you know why? Like, how do I know if I prefer the mean or the median? Well, if it's blank, we prefer the mean. Yes, table 4. Okay, so if it's symmetric, which it is, we prefer the mean. All bell-shaped data is symmetric, right? So in those cases, if it's bell-shaped, we'll always prefer the mean. And then what else is true if we prefer the mean? Yes. Well, that too. But something else we learned yesterday. Okay, let's fill in this and forgot it. Anytime we prefer the mean, we do prefer the standard deviation and the MAD. But also yesterday we learned that if it's symmetric, what else is true about the mean? If it's symmetric, what else do we know about the mean? It's in the middle, so the mean matches the median if it's symmetric. So when we look at like our bell-shaped examples like F, you should be able to tell me the mean of this one without having to do the math. What is it? 4. So when it's perfectly symmetric, wherever you would draw that line of symmetry, the mean will match the median. Okay, so that should save you some time on your unit tests. So lots of things we learned yesterday, now we're applying them. So table 2. For anything that is skewed right, do we prefer the mean or the median? The median. The median. Do we remember why? Or how do you know to use the median? What do we look at? So even if I didn't tell you the shape of it, I should be able to give you like a graph that looks like this and say, which do you prefer? Yes, we prefer the median. What do I look at to tell me if I prefer the mean or median? Yes? Because it's not symmetric. And if it's skewed, it's because there's some potential outliers. All right, that's making it not symmetric. Guys, sit up. We're covering a lot of test questions today, which are taking them exactly 1 week. So we prefer the median anytime it is not symmetric. So things that are skewed are not symmetric. The median is not affected by outliers like the mean is. So for the things that are skewed right, like B is skewed right, would we expect the mean to be higher or the median to be higher? Table 3, can you tell me? If it's skewed right, would we expect the mean to be higher or the median? The mean. Do you know why, or are you just guessing? When we have outliers to the right of the data, do the numbers get bigger or smaller on the number line? Let's go to the right. Bigger. When I go to the right, the numbers get bigger. So if I have an outlier here, that pulls the mean in that direction. My median is probably somewhere over here. This is probably where the middle of my data is. The mean and median no longer match when there's outliers. So in this one, the mean would probably be higher than the median. Really great test question. The reason I'm learning it. But everyone likes to zone out, so we'll just see. Table 4. Whenever we prefer the median, what do we prefer for spread? IQR. Table 6. For anything that is skewed left, would we prefer the mean or the median? The median. Because why? Because it is not symmetric. Table 1, anytime we prefer the median, what do we prefer for spread? The IQR. So you could either know it, I've explained it, or you could just memorize it. Table 2. Whenever something is bimodal, would we prefer the mean or the median? The mean. Table 3, anytime we prefer the mean, what do we prefer for spread? Good. Both, because they could say either one on your test. They're both very similar. And table 4, new person to speak. Is bimodal symmetric? Yes. And all of our bimodal examples, even the box plot, we can draw a line somewhere and it be a mirror image on both sides. So where's the other bimodal? Here. Draw a line somewhere, mirror image on both sides. All right, uniform, table 6. We prefer the mean or median for uniform. Table 1, would we prefer the standard deviation in MAD or IQR? Okay, good. And table 2, is uniform distribution symmetric? Yes. All right, questions, comments, concerns? Okay. We're gonna go to the next note sheet now, but just some brief announcements before we do that. So that was like an additional resource to hopefully help clarify some things and help you study. Today, our other lesson is to interpret standard deviation, which we've been talking about it since the beginning. I've included it. I think the curriculum wants me not to tell you about standard deviation until now. You might as well have learned it from the beginning. So you already kind of know a bit about it. You know that it tells us how spread out the data is, and it's a measure of variability. But today, the new part will be to say something about a situation using standard deviation. You already know how to use technology to compute it. Good. So you just need to now really have a better understanding of standard deviation. I re-record the lessons every year. The math is the same though, so to work ahead, they're there. I also have some other videos for how to use Desmos. We've already covered it, but in case you're still confused, I've never taught you how to do standard deviation by hand. So you can only use a calculator for it. Actually, it's a calculator. I think all the questions on your test though, if you just understand what standard deviation is, you can usually get the right answer without to put it in the calculator. This slide is for the videos covering the graphic organizer, because before we used to do it on different days, like a Monday. Didn't have time this week. The practice is two separate ones, but they're both really short. So make sure you're doing them. Usually all the practices are under 10 questions, so these ones are probably even shorter. So they're working up, they're using that they're assigned. Also, after tomorrow, you'll have learned everything you need to know about Unit 1. So you should take the weekend, make sure that you have all your note sheets, and if you don't, then you go into Schoology, watch the videos, take notes on your own paper, save them for the binder check. If you want papers, you can grab them from here. They're all labeled with the lesson numbers. But you could also do it on your own paper, so that way there's never an excuse for why it's not done. You can't say, oh, I didn't have the paper. You don't need the papers. The papers are nice, but like you can always do it on your own. The list has been on the wall. It's now in the slides. So you can reference it at home. What you should have for your binder check, that is going to be on Tuesday. So I'm going to call you individually on Tuesday. You're going to flip through your notes. I'm going to see, are the parts that we did in class filled out? We don't usually do every single part of every single note sheet. And I don't expect you to go home and do them on your own. Just the parts that we cover in class, I expect to be there. So if they're blank for the parts that we did, then you won't get points for those ones. Okay, but that is going to be your first project grade. So it should be a good one. It should be a nice buffer before you take your Unit 1 test. But if you're not someone who takes notes or doesn't save your notes, that's going to be a bad grade. It's really hard to get above a C, really even above a D if you're not taking notes. So make sure you're ready for the minor check. Start getting it ready this weekend. Also, something you might have noticed, I just haven't addressed yet, but it's right at the top of Schoology. You can't miss it. That's where the study guides will be for your tests. Usually I have them available starting day 1 of the unit, but given that it's your first unit, I didn't want to overwhelm you. But they are there now. You can start working on them. And the first 2 are required. Like if you don't do them by Tuesday or really Wednesday, they will be put in as missing. And combined is 150 homework points. They match the same amount of points that would be for your assessment. So like this portion looks like your 100-point portion of your test. Has like really similar questions, just different numbers, different graphs. And when you take it, that'll be a good representation of how you might do on that portion. It's auto-graded. This one is on a piece of paper. You could grab it early if you want. It's in there. But usually I don't give it out until the day before I plan to check it, because I know you guys don't typically anyway. But you can grab it early if you want. I plan to check it during binder check, and that's gonna be like similar to your constructive response portion of your test. So that's worth 50 points normally for your test. So this one's worth 50 points for your study guide. It's only a few questions. So really, if you just know how to do these questions, you're already securing a third of your assessment grade. So there's that. And then you have a lot of extra credit opportunities, like the ones for IXL that a lot of you have already been taking advantage of. Those go in the project category. Now, it's probably not affecting you right now because there's nothing in the project category right now. So it's probably just like not able to calculate when you have 3 extra credit points. It can't calculate what it should when there's nothing else in there. So once I put in the binder check, you'll see that impact on that category. The other one is also extra credit, but it's homework extra credit up to 100 points. So that's like 10 homeworks. But you've been really slacking on your homework instead of like stressing about it, going back, trying to like make up for it, just to your study guides. It'll be good for your grade, but it'll make up for anything that was missing, and it'll help you prepare for the test that is way more points. So questions on anything I just said? If it's optional and extra credit, it says on the side. Okay, these ones are not, they're required. But you'll have some time in class next week. But the paper one, you'll want to have on the day, show it to me on Tuesday. So yeah, next week is a pretty important week. Make sure that we are using this week to catch up on anything that we're missing. The deadline is next week for papers. And normally you don't get 2 days in class for study guides. The only reason you are is because I have like a stupid filter. Otherwise, we would be doing the lesson that's for tomorrow. We would be doing that on Tuesday, study guide Wednesday, and test still on Thursday. But we're finishing all the learning this week so that next week just study and assessed. All right, that was a lot. Any questions or anything? So now moving on to the last lesson, the standard deviation lesson. So this is not on any of your papers. So just look up at the screen and be able to tell me something you notice and something you wonder. Just you yourself, think about it. Something you notice, something you wonder. Okay, table 6, what do we notice? What do we wonder? Each one has a mean of 10. So I see some people like not on task and you could be doing work, but like I don't really care because I'm trying to teach you right now. This doesn't work if you're not paying attention. So something we notice, yes, all the means are the same. Did you really need them to tell you the mean of every single one though? No. You should have been able to easily see that all the means are the same because why? They're all symmetric. All the means are the same. All shapes of the distribution are symmetric. Therefore, you should have been able to just look at where you could draw a line of symmetry and see, okay, it's symmetric, my mean matches the mean. And that is true for all of them. Other notices or wonders? Raise your hand. Table 2. Okay, so that's a good question. What do MAD and standard deviation tell us about a data set? Okay, variability. In simple terms, what does variability tell us? Not range. I don't want you to confuse range with like maximum minus minimum. So a different word for variability. What does variability tell me about a data set? Okay, so I see some people daydreaming, I see some people doing homework, like this isn't gonna work if you can't learn. So what does variability tell me about a data set? What's another word for variability? So like when I say measures of center, that means typical values, what your data should be clustered around. When I say measures of variability, what does variability tell me about a data set? Like you wouldn't go up to a second grader and be like, oh yeah, that's variability. What word would they understand better? Yes? Okay, good. So variability is how spread out your data is. Why are these zeros for the MAD and standard deviation? Yes. It's not spread out at all. That's when your variability is 0. If you add 1 point to it, doesn't really matter where, yeah, add it over here. What would that do to the MAD and the standard deviation? Would it increase, decrease, or stay the same? It would increase, because now I'm making it more spread out. What would it do to the mean if I put it right here? It would. Right, what word was that? It would not increase, no. It would decrease, because I put it to the left of my data. As I go to the left on the number line, do the numbers get bigger or smaller? So they're different. They measure different things. Mean tells me a typical value. I'm adding 6 to a data set where the rest is 10. That typical value is going to be smaller. But MAD and standard deviation measure something completely different. So that's why one can increase the other. Any other good notices or wondering out there? Okay. So which one looks the most spread out? Tell me the shape. You guys should know the shapes now. And what's the most spread out? You guys have graphic organizers. So today is no, it's not the most spread out. It's something else that's more spread out. And you can confirm it because they have the statistics right next to it. Which one is the most spread out? Okay, and there's actually 2 bimodals, so is it going to be the one that's on the top or the one that's on the bottom? This one is the most spread out one because everything is centered away from the mean. They have the peaks on the very ends, whereas this bimodal has the peaks like at the very ends. And you can look at the statistics. These values give numbers that you can compare and say this is more spread out than that one. And highest MAD, highest standard deviation. I heard uniform, and maybe you meant this uniform, but both of these are uniform. This one would be where it's not spread out. Questions, comments, concerns? Great, we covered a lot of test questions from just that warm up, so if you weren't paying attention, hope you do well on the next test. So we're gonna go to these questions. These ones are printed on your paper. Read them to yourself and be prepared to respond. We'll change them. Or if this is the same. So table 1, why is the standard deviation the same for 1, 2, 3, 4, 5, and then -2, -1, 0, 1, 2? Okay. So I'm not saying that you were the one off task during the warm up, but this is why we need to pay attention to the warm up. The warm up was only on the screen. We talked about standard deviation in math class. What do standard deviation and math tell us? Okay. So why is it that these two random data sets, the one, why do they have the same standard deviation? Okay, what's the difference between 1 and 2? Between 2 and 3? And it's consistent throughout, consistently increasing by 1. And what about the difference between -2 and -1? No, still going up by 1. Then -1 to 0. So, and it's consistent throughout. They are the same amount of spread. Probably to sound a little smarter, we'll say the same amount of variability. But you have to know variability is how spread out it is. So you need to put that in parentheses, something to understand for your own notes. Then do that. But they're the same standard deviation because there's the same amount of variability. It doesn't matter how big or how small the numbers are. Because variability is spread. It's nothing to do with like how big or small the number. Table 2. Why is the standard deviation different for this number set and this number set?
Because the first one outside to counts.
Okay, good. So they're spread out differently, so we should definitely not expect them to be the same. Which one would we expect to have a higher standard deviation? Class, all of you. The first one. So even without doing the math, I know this one will have a higher standard deviation because it's more spread out. So that's how you can save time on your tests. I mean, yeah, they actually are showing you the values and we can put those into Desmos and compare. But that can save me some time if I just know standard deviation is how spread out it is. That should have a higher one. And class, when is the standard deviation equal to 0? So when it's not spread out at all, can you guys give me an example? Okay, so all the same value in a data set. And this is where we ended in my first hour as well. We'll probably do some more tomorrow, but definitely don't use this note sheet because we need it for your minor check. But tomorrow we'll start with this note sheet and then we'll also do less than this week. So your practice, your independent practice, make sure that you're practicing. And if you have questions, make sure that you're asking. If you don't ask before the test, then you'll just never know. I will not help you during it.